Thank you. It's an honor to be here, and thank you to Jonah and to Philippe and to Professor Dehaene and all of you who brought me here. Okay, so I'm giving 3 lectures this week, and today's lecture will be a more general lecture. Sort of covering the field to some extent anyhow, of ideas that I have or that I've thought about. And the second lecture will talk about the aspects of syntax that music and language deeply share. And I'll do it through analyzing poetry as if it were music. That's the way I will approach that problem. It'll be a much more technical lecture than today. The third lecture will be about the aspects of music that really have, as far as I can tell, nothing to do with language. And I will attempt to show you how those non-linguistic parts of music work, and why they're different, and just to give you an idea of aspects of musical syntax that are really quite different. Let me first make an acknowledgement to the Strungman Forum. There was a conference a year and a half ago in Frankfurt, Germany, on language, music, and the brain, and they asked me to make a paper on the relationship of musical and linguistic syntax. Today's talk is partly based on that position paper. So a few general things before I get into some more details. So why are comparisons between language and music so common? One could give all kinds of reasons, and I'll just list very quickly some of them. Both domains consist of organized sound and time. The two domains appear to be uniquely human, at least in any highly developed way. They appear in all cultures. They're complex, communicative, expressive, and meaningful activities, meaningful in whatever sense. They both employ rhythm and contour. They come together in poetry and song. In fact, in some cultures, in ancient Greek, for example, poetry was referred to as musique. The huge distinction between poetry and music that we think of now, it didn't exist in all cultures. And I think now to be a little more technical, both domains generate potentially infinite output from finite principles. Sometimes these are called Humboldt systems, where you have a limit, basically a limited set of rules or principles that can produce an infinite output. Of course, language has this generative capacity, and so does music, given whatever style in question. And both domains are organized hierarchically. So those are some of the reasons that language and music are compared so often. But there are differences. Music does not have anything like word meanings. Music doesn't have semantics in a linguistic sense. Music doesn't normally refer to things. It is true that Beethoven in the Pastoral Symphony can refer to a thunderstorm. So it's possible for music to imitate, but that's really not essential to music. It's something that music can imitate, but in its essence, music is not referential. You don't have different words, things like different kinds of musical things meaning the same thing. You don't have truth conditions if a statement is true or false. You don't have entailment, et cetera, et cetera. So semantics in a linguistic sense really is not central to music. Doesn't seem to have much to do with music. Music does not have parts of speech or phrasal categories, noun, verbs, adjectives, etc., noun phrases, verb phrases. And music does not have a system of phonological distinctive features and other aspects of some other aspects of phonology. On the other hand, language doesn't have fixed pitches and intervals. This is also true of tone languages. In tone languages, the tones are relative to one another. A woman and a man can speak at different levels, or you have declination of an utterance as it continues over time, typically, and yet all these things are understood. So pitches in tone languages are also not fixed, and we don't have fixed intervals in in any languages. Language doesn't develop degrees of consonance and dissonance, which is essential to most musical styles. Language does not have scales or harmony or counterpoint, although James Joyce reputedly tried to put counterpoint into Finnegan's Wake. Language does not have tonality in a more general sense or hierarchical pitch relations. It doesn't have pitch space. Pitch space is my term for the system of closeness and farness of pitches, chords, and keys. So if you're at a certain point of reference in a tonal system, other pitches or other chords or other keys are either close or distant, and these things are well studied empirically and developed in my book Tonal Pitch Space quantitatively. So it's a very important part of music theory and music cognition, but it doesn't seem to have any counterpart in language. Music has tenses and relaxes as you listen. Pitches and chords are attracted to one another in varying degrees, and language does not seem to have these features either. I'll just refer very quickly to the fact that there's a long history of dealing with musical syntax in ways that are relatable to linguistic syntax. Zarlino was a 16th century theorist. Fuchs was Bach's contemporary. And the whole syntax of intervallic relationships, if you have a dissonance, how do you treat it, and so forth. How do two lines combine together to make counterpoint, counting all the intervals and the categorization of intervals. All these things are still part of our pedagogy in basic training in music theory. In the 18th century, also a contemporary of Bach, Rameau started to develop, he abstracted to the level of harmonic progression and developed for the first time a syntax of harmonic progression based on the Bass fondamentale and what kinds of progressions were possible from that. His contemporary Mattheson in Germany developed ideas from classical rhetoric, going back to the Roman traditions of rhetoric. And this is a tradition that preceded Mattheson and continued afterwards. And you still find occasionally people trying to deal with the terms of classical rhetoric in terms of musical rhetoric. I think it's an area that deserves further exploration, but it hasn't been done yet in a way that's very systematic. Coming out of this, it was later in contemporary of Mozart, Koch took the rhetorical tradition and made an organization of phrase types, which then in the 19th century, around 1840, 1850, out of Bernhard Marx, developed a sort of a pedagogy of form, which is still part of the basic training about, for example, how sonata form works. And it's organized around certain kinds of phrase types. Later, toward the end of the 19th century, Hugo Riemann developed a syntax of harmonic functions. He didn't quite develop it actually, but one can infer from what he said how one might develop a syntax of harmonic functions. And then we come to the 20th century, Heinrich Schenker, a very important music theorist, who really developed a proto-generative system. I'll speak a little bit more about that in a moment. And then now to our contemporaries, the idea of musical syntax as harmonic functions acting like parts of speech is an idea that, as far as I know, first was initiated by Alan Kyler in the 1970s in the States. He didn't develop it very far, and Martin Rohrmeyer very recently has developed that idea in a more sophisticated way. I understand he's given a talk fairly recently here, so and I've thought about what he's done and why I disagree with it and so on. But it's very interesting work, which I may turn to at a later point in these talks. And finally, musical syntax is a minimalist generative linguistics. Jonah Katz and David Pozetsky have written this paper, which I wish they would finally publish because it's very interesting, in which they take the components of generative theory of tonal music and really slot them into minimalist theory. It's a kind of a extended thought experiment in which it's very thought-provoking and very interesting to me. And it's not what Jackendorf and I did, but at least, I mean, for just one example, the whole relationship between and the derivations of how Jackendorf and I derived pitch reduction. We had two kinds of reduction, time span reduction and prolongational reduction, and we had this whole way of doing it, from deriving one from the other. And they've proposed a way of doing it, which I think which really helps me. So I'm regardless of the rest of what their paper does, that part of it is, I think, important for my own thinking. And finally, there's, as I guess I didn't realize that Ani Patel and Isabelle Peretz had been speaking here, but there's a huge amount going on in neuropsychology and, of music and the cognitive neuroscience of music. And clearly this is a very important part of where music theory and the cognition of music and its relationship to language will have payoffs in the future. Now back to Schenker. When I was first getting interested in these kinds of things, I, along with many other people, was aware that Schenker, whose main theorizing took place in the 1920s and 1930s, was really making a kind of proto-generative theory along the lines that the earlier Chomskyan theories were doing. So this is basically how it looked. With Chomsky, you start off with the sentence node, the S node, and you have a bunch of phrase structural and transformational rules, and the output is a grammatical sentence. So in the same vein, if you want to put it this way, Schenker's theory starts off with something called the Ursatz, or the fundamental structure. It's a posited structure, which I could play at the piano, but anyhow. And then you have a bunch of elaborational and transformational rules, and you end up with a piece of music. Basically, it's that is a fundamental structure. Okay, so it's about as good a fundamental structure as you could imagine. I suppose if one wanted to pick one, but it really is a lot like the kernel sentences in Chomsky's early theory. So Jackendorf and I, when we started working together, I want to say one thing about when Jonah introduced how we got started with this. It's true that we responded to Bernstein. We met because Bernstein was giving the Norton lectures at Harvard. But actually, my own motivation and my whole idea about doing a generative theory of music came out of my needs as a composer. I was desperate to find an intellectual foundation that would escape the confusion of musical styles that I saw around me in the 1960s, where all these different composers were creating different kinds of systems, and most of them were unhearable. That is to say, you could decipher the systems, but you couldn't perceive what the systems said. So a composer would compose by a certain method, but the way he composed didn't translate into what you would hear in any direct way. So all of this really troubled me, and I wanted to have a different kind of intellectual foundation for my composing. So when I read Chomsky's early work, Language in Mind was the first book I read. A light went off in my head, and I thought, oh, okay, if you can study language as a cognitive capacity by making a rule system that predicts what happens, then why can't we do that for music? And Jackendorf had, quite independently of me, had a similar idea. He had just studied with Chomsky and Morris Halle at MIT, and he was a very fine clarinet player and had that idea separately. So when Bernstein came to give his Norton lectures, we already had the idea of what we wanted to do. But we met because of Bernstein, because everybody was talking about Bernstein's lectures, and everybody was disagreeing or agreeing or whatever it might be. So Ray and I met through a mutual friend, and we made our first presentation to Bernstein directly with a group of about 10 people. It was a totally incoherent presentation, but it was a beginning. Anyhow, so we rejected this sort of Chomsky-Schenker analogy as a way that we wanted to proceed. And the reasons why, was we didn't see any theoretical justification for the Ursatz as a point of origin. The Ursatz really comes out of Hegelian and sort of idealistic German philosophy from the early 19th century. Goethe's Urpflanze, that kind of thing, the Ur plant that would be the plant that sort of has all the characteristics that real plants have, but which is sort of an idea rather than an existing thing. It's kind of a pre-evolutionary idea of a sort of Platonic ideal. That's the way Schenker thought of the Ursatz, but it's very hard for us modern people to think the way that Schenker did. So I've never been happy with the idea that you start with some kind of primordial object as out of which everything else comes. And then another problem is that the Ursatz, or anything else you would pick as your primordial object, is restricted by its time and culture, by its style. And so, Jackanoff and I wanted to build a theory that would be generalizable to other music, and it isn't. And of course, Schenker would agree because he rejected all other kinds of music. And then the whole question that came up was how do you introduce rhythm into the derivations? Schenker's pitch theory, which is, was a great music theorist and influenced me a great deal. But and he had interesting observations about rhythm, but he didn't really have a way of introducing rhythm into the formalism, the quasi-formalism that he was developing, because he never was totally formal. Then another thing that I think is really important is that even if you're able to derive structures from some primordial object, what does it say about psychological processes? Well, it's not very clear. And that troubled us because we wanted to make a psychological theory of musical understanding. So for all these reasons, we rejected that approach. What Bernstein tried to do was that he would take something like this flow chart and say, well, okay, language has phonology, syntax, and semantics, and so how can we slot music into that? And so you might imagine something like this. You might ask, what is a musical verb? Something like that. So we didn't want to do that. We didn't want that to just pursue analogies of that kind. So this is how Jackanoff's and my theory, I'm going to call it GTTM now, and the second book I'm going to call TPS, just for brevity's sake. And this is how the entire theory does not relate to generative linguistics. There's no search for these analogs, counterparts in phonology or syntax or semantics. And maybe most importantly, no attempt to generate grammatical sequences, musical sequences in a given musical idiom. Here's how the theory does relate to linguistics. It relates in terms of its broad goals and methodology, rather than analogies or specifics about language. The whole first part of Chomsky's Aspects of the Theory of Syntax, which was published in 1965, still seems to me a wonderful document about the goals and methodology of linguistics, and so that was really the basis for our thinking. So our goal was to characterize the musical capacity by means of a rule system, or in other words, to generate structural descriptions of existing musical sequences in a given musical idiom. And these structural descriptions are intended to model structure inferred by an experienced listener, that is to say, a listener experienced who's been acculturated to a musical idiom. So in other words, not the first flowchart here, where you take sort of whatever is available as musical elements, you have a bunch of rules, and then the output would be a sequence of events. That didn't interest us. And in fact, we tried to do it at first, and when we started doing it, it was really boring. That was another thing to generate sort of trivial musical sequences was not interesting. And in fact, even though that was the early paradigm of generative linguistics, it seems to me that linguistics as practiced is much more concerned about structural descriptions about you take a sentence and another sentence, and you have all this data, and you try to understand, to explain, what's happening in the sentences. What are the structural descriptions? What deeper level of explanation can you have that would unify disparate phenomena? So it seems to me that linguistics as practiced follows something much closer to what we did, which is the lower diagram, where you have a musical surface of a sequence of events, you have a rule system, and you have the herd structure, or the structural description, as output, which is intended to model and basically predicts what listeners hear. And I'm not going to spend much time on this slide because I want to talk about other things, but there's all kinds of there are various idealizations and limitations to the theory that we took, some of which came out of Chomsky's work, and many of which, in fact, have been followed by music theory traditionally. It's just that we stated explicitly what these things were. Some of the limitations at the bottom that I list are that I've since generative theory. I did expand the range of the theory in tonal pitch space to quite a bit more music, and I've showed how to get beyond the idea of a single stream of events. That idealization or limitation was that if when you hear music, you hear a sequence of events, but in fact, in much music, you have simultaneous sequences of events, which are musical streams, to use the term that Albert Bregman used in his important work on auditory scene analysis and auditory stream segregation. So that's basically polyphony and counterpoint. And of course, in most polyphony, the independent voices also relate vertically. So we all know this, but we didn't. Jackanoff and I didn't work with that because it would have made more complex what we were doing. But in tonal pitch space, I sort of show how one can handle that problem in terms of the theory. So I've gone beyond the initial limitations to some extent. And there are different kinds of rule types, which I'm not going to talk about much today. I just list them to say that the well-formatus rules basically say what's a possible structure in a hierarchical way. Transformational rules play a very small role in our music theory, unlike early generative linguistics. Preference rules were our big innovation in terms of rule types. Those are basically anticipated neural networks and optimality theory in the sense that you have this principle and that principle, and they might reinforce one another, in which case you have a very strong judgment, or they might conflict with one another, in which case you might have ambiguous judgments. So what the preference rules come together, they come out with a top result, but in most cases. But it's not categorical. This is grammatical. That's not grammatical. Rather, it's degrees of coherence that the preference rules predict. So that was the innovation in rule types that we developed in GTTM. Then finally, in tonal pitch space, I developed various kinds of algorithmic rules, which are very totally quantitative, dealing with issues in pitch organization. Just very quickly, these are the components of the GTTM theory, where you have a musical structure, a musical surface, and you have the rhythmic components of grouping and meter, and they come together into the rhythmic component of time span segmentation, which basically says that you hear an event in nested time structure. So you're hearing an event on a certain beat in a certain phrase, for example, and time span segmentation locates all events in the time structure, and you hear, segments are contained within segments, so it's very hierarchical. And out of that comes time span reduction, which selects the most stable event in each time span recursively, and then prolongational reduction, which derives from that, which describes patterns of tension and relaxation. So those are the components of GTTM very briefly. And these are the ones I added in tonal pitch space, in which I will not talk about to speak of today, but I will in my third lecture. And those are the parts that have basically less to do with language than the ones in blue. So I want to emphasize that GTTM and TPS developed strictly musical components. They're not, so we developed a music theory that didn't pursue direct analogies. So now, at this point, one might ask, what then what connections that really have substance are there to be found? And I would argue that we must proceed at a much more abstract level than analogies. So that's what I'm going to do right now, and then I'll illustrate with some musical examples. So the next section of my talk is about groups, grids, and trees. First, I want to define syntax in a rather broad way. Let syntax equal the hierarchical organization of a string of discrete objects, or of features belonging to the objects. And in linguistics, this definition includes aspects of phonology as well as linguistic syntax, as we'll see. And it also includes major aspects of music. So I'm interested in a broad definition of syntax. So what are the objects in question? One can have various kinds of linguistic objects. For my purposes, a linguistic object is a syllable or a word. So a syllable contains phonetic features and phonemes and so on, but we won't be concerned with those directly. A musical object is an independently attacked unitary sound, usually a pitch or a chord. It could be, in drums or something like that, where the pitch is not clear, but usually it involves pitch. And of course, a pitch contains lower-level features that we're abstracting away from. And it's noteworthy, it's an obvious point, but I think it needs to be said, that when you set words to music, syllables are realized on pitch events. So this reinforces this basic statement that I've had about what these objects are. Now, it's true that sometimes you have a melisma in music where you have a syllable over several pitches, but by and large, on average, syllables are realized usually on one syllable per pitch event as a rule. So now we have our objects, and then what kinds of organization do they have in a hierarchical sense? So I'm going to divide these into these three categories. Grouping structure is something that doesn't belong just to music. It doesn't belong just to language. It's ubiquitous in human behavior. So we have an object here. I've just listed 5 objects, and I've named them 1, 2, 3, 4, 5. And I've just given here just an arbitrary grouping just to show you the form of grouping. So what this says is that the objects 1 and 2 group together, and objects 3, 4, and 5 group together, and at a larger level, all of them group together. In real life, of course, we might have many more levels than this. But you don't have things like these, where you have groups where 1 and 2 are grouped together, 4 and 5 are grouped together, 3 is all by itself, and it's not grouped together at all at that level, but just groups it. But when all of them are grouped together, then 3 is grouped at the next level. That's not permitted in our theory. Or the bottom case, where you have groups where 1 and 2 are grouped together, and 3, 4, and 5 are grouped together, but at a larger level, 3 instead groups with 1 and 2. So that wouldn't happen. So there are various well-formed constraints on how things group, which apply equally in music and language, I think. In music, the objects are motives, musical motives, like pa-pa-pa-pam, subphrases, phrases. A phrase in music is essentially equivalent to a sentence. As usually, or an intonational group, to take a phonological category. It's the unit that breathes most naturally as a complete statement. But then the phrases themselves group into larger units, such as periods, and then you get sections, and finally you might even have movements. So all of those things are groups. In language, you have up to the level of the sentence, they group into prosodic units and into syntactic phrases. In language, above the sentence, objects group into units of discourse. Of course, so much of linguistic theory is just about up to the level of the sentence and not above at the level of discourse. It's very hard to be formal at the higher levels, which is interesting, and it's worth discussing what is musical discourse. I'll have a few words about that later on in my third lecture, probably. So that's the basic form of groups. Now, here's a grid. A grid is different kinds of grids, but in the grid that I've shown you here, we have something assigned to a syllable or to a pitch event, and in this particular one, they're equidistant at the bottom level. And then at the next level up, if an event is for some reason more important at the bottom level, then it's also, if an X is felt to be important at the bottom level, then it's an X at the next level. So that continues up in 3 levels in this abstract form of a grid. So grids, these X's belong to syllables or to pitch events. In language, they take the form of stress grids and metrical grids. A terminology question here for reasons that escape me in linguistics. When they make stress grids, they call them metrical grids, which is clearly incorrect, which I'll get into it later. So I'm making this distinction between a stress grid and a metrical grid. A metrical grid has constraints about periodicities that a stress grid doesn't. And in music, grids take the form just of metrical grids as a rule. And you might ask why stress grids don't usually appear in music theory. In music, we have a distinction which I think is very important and doesn't really exist in linguistic syntax, a distinction between salience and stability. When I say salience, I mean prominence or stress. A stress in phonology is a sort of multidimensional phenomenon. It comes from various factors, which I'll get into in my second lecture. So you have stressed syllables, and when you have an utterance, you have things like nuclear stress and so on. But you don't. In music, you also have pitches and chords as more stable than another, and this is very finely calibrated in music. It doesn't really exist in language. So in the syntax of tonal music, stability normally overrides salience. When you're talking about the syntax of music, it's what's stable or unstable that matters. And something might be louder, or might have a lower bass note, or for some reason, or might be longer. Things that would, or higher, things that would come out as standing out as more prominent or more salient. But those are sort of ripples on the current of musical syntax, and the stability overrides the salience. It's interesting that in atonal music, almost by definition, stability doesn't exist. You don't have all these distinctions of stability. So then what's more salient plays a much bigger syntactic role in atonal music. So there one might say you really do have a stress system somewhat comparable to the linguistic one in phonology. And the whole idea of stress grids are evoked in GTTM's time span reduction rules. Some of the rules that bring out more prominent things as opposed to more stable things. And I draw on them rather heavily in my theory of atonal pitch structure in tonal pitch space. But they're not listed in terms of grids. And it might be interesting to do that. It's something that nobody's really done. I don't know that it's possible to do that in a systematic way. But anyway, that's something that interests me, to consider what a stress grid might be like in the musical case. Now to my third category of trees. I'm using trees basically, equivalent to headed hierarchies. Headed hierarchies come out of X-bar syntax, which was developed in the 1970s. in linguistics. And this is a very simplified, in the cases A and B, a very simplified representation of that, where you have two objects, X and Y, and if X dominates, then it dominates that phrase, or Y might dominate. On the right, cases C and D are this is the notation that Jack and Off and I developed for in GTTM for the same thing. So those are equivalent notations. And the headed hierarchies take places over sequences of events in music. And in language, they take place over phonological, syntactic, or semantic units. So they're all over the place in language. So now I'm going to start illustrating these things. And I picked, figuring this is for a general audience, we'll do this Beatles song, which I'm sure you all know. So let's start off with the word yesterday. So we have three representations which are basically equivalent notations for this. The first one comes from Liberman and Prince, some kind of, it's close to what they did. Then in the 1980s, people started using stress grids. They call them metrical grids. So you put an X on every syllable. If it's stressed at the next level, then it gets the second level stressed, and then the third level yesterday, because you say yesterday, not yesterday. So that's the stress grid for yesterday, the word. And underneath it is how the syllables are grouped. All of this can also be represented by a time span reduction tree, as in our music theory on the right. So it has the same information. So and I'm going to go into the whole methodology of stress grids and metrical grids in much more detail in my second talk. But I think I can appeal just very quickly on an intuitive level. If we take the first line of the song, of the lyric, yesterday all my troubles seemed so far away. We've already got the stress grid for yesterday. All my troubles. My is cliticized. It's pronounced as if it belongs to the word troubles. So my belongs to troubles, as the prosodic grouping shows underneath. And as you say it as one word, my troubles. But all we make a distinction between content and function words. All has more stress. But troubles, in that phrase, all my troubles, the trub receives the greatest stress because it has nuclear stress, which is a tendency in English, German, Italian, I guess French to a somewhat lesser extent, where the stress goes on the main, on the last word, on the most prominent syllable in the last word. If it's a polysyllabic word, if it's a monosyllabic word, then on the last word. And then seemed is a content word so far, and then away. The trouble seemed so far away is a phonological phrase, and so that's stressed. And then the whole thing, yesterday, all my troubles seem so far away. Away wins because it's its nuclear stress places it at the end of the utterance. Now, in the metrical, what happens in the music theory, and what happens in linguistic theory too, I think, is that in poetry anyway, is that if there's a certain periodicity to the way an utterance is stated, then you start to develop a metrical grid, in which there's isochrony at a given level. And you basically try to match up the stress grid with the metrical grid with a minimum of violations. Now notice in the metrical grid that I have there, underneath it's an upside down grid. I think you can read it upside down. I have the X in parentheses where the comma is. I'm assuming that there's a little bit of pause there. So you can, if you accept that, then the metrical structure is very regular, duple meter, da 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 between the first and second levels. But at the third level, it's in triple meter, da 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 da. So, yesterday, all my troubles seem so far away. Yesterday, all my troubles seem so far away. Okay, so that's what that metrical grid is saying. So this is a now it doesn't mean that the Beatles sang it that way necessarily, but this is what the analysis would do, regardless of how the setting works. So without going into the derivation further, since I'll do much more of that in the second lecture, I'll just show, well, first I want to show this, which is that all of this can be represented as a prominence tree taken from the music theory. It's an equivalent notation. Once you have the metrical grid, you can assign note values to the first level. Yesterday, all my troubles seemed so far away. And you can say it, and then I can rhythmicize it and put it all in musical notation. So what I've done that here. Yesterday, all my troubles seemed so far away. And notice that each of the downbeats is now, I put it a little bit higher. That's because those are the most stressed syllables, and pitch height is the major contributor to stress. So I've just done that as a kind of fairly natural reading. Yesterday, all my troubles seemed so far away. So you might expect that would be how the Beatles said it. They sort of did, but not quite. So this is the Beatles song. Underneath what I have here, sometimes the screen may be a little small. I don't know if you're having trouble reading it, but I had to fit it all on one page. This is the first phrase. Underneath is an upside-down metrical grid with the note value from the span from one X to the next shown at each level. And here's how they sing it. So, yeah, well, we'll spend more time with this in a minute. But first, to go any further in the analysis, I have to introduce the prolongational tree and what it means. Essentially, if you have a right branch, which is case A, it's a tensing motion, which means that the second event is less stable than the first one, or the reverse, a relaxing event. So, case A, oops, I don't have any sound on my keyboard. Okay, now. Okay. So that says that we're tensing from this to this, and then the very reverse, and then we can put them together. There, I've got 4 events. What this says is that this is stable. It becomes a little less stable. And then it'll come to this, and then it resolves there. And it says that the first event and the last event are the same, and that those contain the ones in between. It's the most simplest possible progression. So you can have, in any given piece of music, you can have a highly complex structure built out of these left and right branches. So this is the tree now for yesterday. I'll play just the opening phrase again. The rhythm that McCartney sings in Far Away is not what I have notated. It's because I took it from the fake book, from the printed score. But he sings it. I would renotate it the way he did it. So what this is saying is that we start off with a dissonance, then it's very stable. And then we come to here, dissonance, and then it resolves. So the pace of phrase is basically going from here to there. So those are the events that have the high branches, and in between we get a departure, and this resolves to here. So you get the tension, and then increasing tension in the middle of the phrase, and then a bunch of details, but basically it's relaxing into the D minor chord. And what's happening musically, is saying yesterday, all my troubles seem so far away. So the music moves far away to another key. That's what it's showing. The notation underneath is in using just slurs, and it shows the same information. So you don't need a tree to show these things. You can use the slurs. So it's like bracketing for tree structures in language. You can do the same thing. The second phrase, or sort of some sound, has this structure. I didn't have room in this. I wanted to make sure that those were clear enough, big enough, so I separated it into two slides. But if you'll notice that I have the level is labeled by, the top you have level A, and it connects to level A there in the second part. So those those two branches would connect up together. So what this is saying, that this is saying that the music is coming back to the point of origin, and now it looks as though they're here to stay. The troubles are here to stay, so it goes back to where it started, and they're back where our troubles are. And then what happens? All of that is just an extension of having already arrived on here. And we're back where we are yesterday, which is where the music started off when he said yesterday. So the music, and in terms of the actual content of the words, the music works very much in sync with the meaning. Okay, underneath I have the grouping structure, and I put in the Roman numerals for the harmonic analysis, if anybody wanted to talk about that. So then one might ask, well, what is the syntactic structure of this statement? I confess I was having trouble with this. I was a little ashamed of myself, but I was having trouble making a good syntactic tree for this. So I sent it to my friend Ray, and he came up with this analysis, which I'm not even sure I agree with. But he said it was difficult. So my biggest problem was what to do with the word yesterday. I didn't know where to put it in the syntactic tree. I mean, it acts adverbially, but it's a noun, and I thought it would be modifying the verb seemed, but he thought it modifies the sentence as a whole, that it comes in at the S node. So whether you buy that or not, it doesn't matter to me, but anyway, that's what he did. What we have is the noun phrase, all my troubles. Troubles wins. It's the head of the noun phrase. We have possessive pronoun my and a quantifier all coming together there. Then we have the verb phrase. The verb is seemed. That wins that's the head of the verb phrase, and then it's followed by a prepositional phrase where away is treated as a preposition, and then beneath that is a quantifier phrase, and far as the head of the quantifier phrase, and so is a degree of quantification. So that's the analysis there, and it looks very different than the musical tree. And so now we'll see exactly how. The first point to make is just to reinforce things said before, which is that linguistic syntactic trees represent grammatical categories, that is to say parts of speech or phrasal categories. But musical trees represent elaborative relationships without grammatical categories. This, to me, seems to me an absolutely fundamental difference between linguistic syntax and music. What I'm saying doesn't apply to phonological trees, by the way. Where the resemblance is much closer to music, and where I'll spend some time in my next talk. So if we compare I've made a little diagram here that I hope you can read this. I've capitalized the most stressed syllables. Yesterday, all my troubles seem so far away. Now it looks as though they're here to stay. Oh, I believe in yesterday. And so I've those are all on downbeats in the music, and they're all, in fact, they're all on dissonances. But the dominating words in the syntactic tree are really very subordinate to the musical tree. You recall that it's troubles is the head of the noun phrase, and seems is the head of the verb phrase. But they're just flying by in the music, So yesterday, all my troubles seemed so far away. Also, you may recall that when I did my stress analysis, I said yesterday, all my troubles seem so far away. But what McCarthy does instead is all my troubles seem so far away. So what he's doing here is he's applying the principle of focus because he wants to say it's not just that they're away, it's that they're far away. So he's really emphasizing that the troubles seemed far away, but very far away. And likewise, they're not here to stay, but they're here to stay. So he's conveying further information by focusing and thereby varying the intonational pattern. So what is prominent in the musical tree are the rhyming words. Yesterday, if I treat it as a whole word, we have yesterday. The yes is dissonant, but the word as a whole, if you take that as a unit for present purposes, yesterday is very high in the tree. Then all my troubles seem so far away. Away wins. Then now it looks as though they're here to stay. That's where he comes back to F major, to the tonic, and then yesterday where it prolongs the tonic. That's where they match up in terms of the rhymes, not in terms of the syntax. And the stressed syllables on yesterday and the focus on far and on here, all those things are all on dissonances, which then resolve down by step into the basic sonority. So these are all dissonant events on downbeats. And what the dissonance does is bring out in a way, it makes it more prominent, and thereby working together with the prominence of the stress grid. So that's basically how the two patterns match up or don't match up. But I think maybe the biggest thing to take away from this is that what's important in the syntactic tree doesn't show up in the musical treatment, nor would it show up really in how you would say it. But how you would say it really has to do with prosody, and that's where the real connection is. I also want to say, this is an aside, but I think it's an interesting one, that everybody loves this tune, and it's actually quite complex. And the larger groupings are ambiguous in an interesting way. And this shows up in GTTM's rules and through a conflict between the principle of symmetry and the principle of parallelism. So if we look at this, yesterday, all my troubles seem so far away. You say that's the first part, and then we say it, and then now it looks as though they're here to stay. Oh, I believe in yesterday. So that's the second part is a little bit longer than the first part, but it's basically fairly symmetrical. And there's a little pause in the music right in between, and it fits with the words. So that would be. We all agree on what the groups are at the smallest level, but the second level down, I have grouping by symmetry. And so what that says is that we have A plus B, and then B plus A, or B prime plus A prime. I'm calling it them A and B because yesterday is a unit. Then all my troubles seem so far away. So you get that's da 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 da. That has the same rhythm basically and goes stepwise in the same way that the second one does. So that's my B prime, and then the A prime is all around, basically around the F major chord again. So I'm breaking it down motivically in that way. But by parallelism, it doesn't work out symmetrically, because what you have is yesterday, all my troubles seem so far away, and now you get what we would call a phrase extension in sort of classical music theory, where now it looks as though they're here to stay. All my troubles seem so far away, now it looks as though they're here to stay. So those two are parallel, so they belong together, so that the grouping by parallelism would put those together. And then finally we get the extension at the end built around the word yesterday, which corresponds to the word yesterday at the beginning. So we have two groupings that are in conflict with one another. So this would come out as a kind of ambiguity in the grouping structure, which I think is kind of nice. The prolongational tree actually fits much better with grouping by parallelism than it does by the symmetrical version, for what it's worth. So now I'm at this point, because I'm trying to give an overview in my talk today, I will talk about some other issues that seem to me of interest. And I'll do these much more briefly. So I'm going to talk about constituent and non-constituent hierarchies, about constraints on sequential ordering, structure at global levels, contour, I'll just touch on contour, a little bit about universal grammar, and then something about the origins of music. And of course, this is, one could spend an entire lecture on any of these topics. So in music, if you have two paired phrases, I've picked antecedent and consequent, and they're grouped together to something we call a period in music analysis. You have the antecedent and you have the consequence, but just as groups, one doesn't dominate the other. So one isn't a constituent of the other. Rather, they are two groups that belong together in something called a period. So they're non-constituent hierarchy. Likewise, if you take just a metrical grid by itself, this is just in 4/4, and I picked a Becquerel. You have a weak beat, like take the second beat of the first full measure. It doesn't belong as part of the grid either to the first beat or to the second beat. Rather, it's just in between. So you have, and that's it. However, when you take the grouping structure and the grid together, then you start to get distinctions in which they become a constituent hierarchy. So in this case, we get, this is an upbeat. That's an F. Here it's I'm picking the fourth beat of every measure. The fourth beat here is an upbeat or a pickup. Da da da. That's all together, and it's not a pickup. It's rather an afterbeat. But now if I cadence. In the same pattern in the second phrase. So you can see that from the groupings underneath from the time span segmentation, which is an algorithmic part of Jackendorf's and my theory. It just is signed automatically. You have a grid, you have the phrase structure, and out comes the time span segmentation from that. And so what the time span segmentation does is to explicate formally the intuitions that we have of upbeat and afterbeats. So if something like a fourth beat now actually belongs to something before or after. So now it's part of constituent hierarchy. It seems like a picky distinction, but I think it's an interesting one. If I were to do this is the prolongational analysis of this of these two phrases with the time span segmentation underneath. I'm not going to go through it now, but you can see that there are right-left branches, that there's always something dominating another thing. So to summarize very quickly, in music, a metrical grid all by itself is non-constituent. And I haven't gone into the basic pitch space structure, and I'll do that some on Friday. Grouping structure, I did go through. All those things are non-constituent. And in language, if you take the prosodic grouping all by itself, the same thing holds true. Same with the stress grids, same in metrical grid in poetry. But when you start combining things, and you get constituent hierarchies, you get the time segmentation in music, and you get the prolongational trees. In language, prosodic hierarchy results from a combination of the stress grid and the prosodic grouping, and then you get a constituent hierarchy. Syntactic relations, obviously, semantic structures would be also, if I were to discuss them. Now, turning to the issue of sequential ordering, in some languages, have case markings that specify grammatical functions. You can have very, word order can be quite free, Latin, I guess, various Slavic languages, and so on. Other languages rely on word order to denote grammatical function. Mary hit the ball hit Mary. It means it's rather different. It depends on the word order. And in certain languages tend to emphasize left-headed phrases or right-headed phrases at multiple levels. Languages tend to slot in one way or the other. Japanese would be one way, English would be another. And you have syntactic movement in language, which is very common. Now in music, there doesn't seem to be any equivalent to these things. There doesn't seem to be any, we don't have anything like case markers in music. As far as I can tell, there isn't syntactic movement of any kind. Katz and Pazetsky argue for it in their paper. That part of the paper escapes me. Instead, we have other kinds of things the constraints in music that order things. There's something called normative structure in GTTM, and I develop it much further in tonal pitch space. The basic idea is that a phrase will typically tense and then relax. So we get right branching followed by left branching. It can take, there are various slightly different forms. Here I've just shown it in one of the typical ways, where you get a tonic at either end, and you have a departure that tenses, and then you have cadential preparation that leads into a cadence. We also have various schematic organizations which are, which greatly affect the order of how things happen. So you can have, I've already discussed a period, at least in abstract. Usually there is a temporal constraint. They're symmetrically organized. In this case, I have 4 bars plus 4 bars. That's what those numbers mean. Or you might have something that's called a sentence in music, or a Satz auf Deutsch, where you have a statement and then a counter statement, which are paired statements which are of equal length, and then you have a continuation and a cadence, which is of the length that's of the combination of the statement and counter statement. And then my colleague, American colleague Robert Geerdigan, has developed a whole list of schemas that happen in galant music, music of sort of pre-classical and classical period of various kinds. I'll illustrate these in a moment. Here it looks, I've written it out a little bit almost like a rewriting rule scheme. Abstracting to an underlying level of the opening phrases of yesterday, we get just a representation of the normative structure of tension, relaxing. So we get going to the first phrase, and then that's prolonged. So that shows you the tensing, relaxing of the basic structure. I think you all know Beethoven's Fifth. This shows just a typical example of sentence form. It sort of happens at multiple levels, but the most important level is where I have statement, counter statement, and continuation. Oops. Well, I don't think I need to play that again. You all know that, right? Okay, so never mind. This is all over the place in Beethoven, this kind of pattern, and it's very predictable. Now the galants, I'll play this one at the piano. This is an early Mozart sonata. So here, what I've shown above is the prolongational tree that shows you the normative structure, but underneath it we have all these little schemas that Geerdigan explicates. This one's called the Romanesque. That's get that, and then you end up going from the tonic to the dominant. The font is this. Takes various forms. It's basically that pattern, where you go to what we call the supertonic, and then we go resolve to the tonic in some form. Underneath it is a printer, which is, or so all of those are happening all at once there. So these are sort of stock things that happen in music of this period, used again and again by all kinds of composers, great and small. And so what's interesting to me about this is that these particular little miniature schemas happen in certain places, not others. A Romanesque will almost always happen at the beginning. A font or a printer will almost happen at the middle, and then perhaps leading into the cadence. And of course, the cadence will always happen at the end. And the reason for that is because of stability. Because starts with stability and then goes to instability. The font and the printer, clearly unstable, leading to relative stability. And then the printer goes on to the cadence. So because they work together with the normative structure, they happen in certain places. So you end up with a kind of a sequential ordering that's quite constrained. So to summarize this part of the talk, schemas often interact. I wanted to say something about statistical explanations. Some of my colleagues always want to explain everything by statistics. So you might look at a huge corpus of music and find that these things happen, and then so they would say that when we learn a musical style, basically we're just registering the statistical occurrence. But these kinds of explanations basically don't go very deep as far as I'm concerned. So what interests me is, well, if you have a statistical pattern, why does it happen? Why does it happen that way as opposed to another way? In order to do that, you have to get into all these structures that I'm talking about. So that's my little polemic on that subject. There are different kinds of expectation in music. Schematic expectation is a very important part of it. And the way when they interact as strongly as these ones do here, you end up with very strong expectations once you've learned a musical style. So that just as an aside. Now I want to talk a little bit about structure at global levels. Yeah, that's the linguistic situation. But the question is, how is global structure represented in music? GTTM's trees go all the way from, single events up through a phrase, all the way up to a piece that might be, 15 minutes long. And this idealization, if you want to call it that, has been criticized, I think, with some justification. We did it for two reasons, and what I suppose we were following in the Schenkerian tradition there. But this was part of our idealization of the theory to a final state of sort of idealized knowledge, rather than any claim about what any particular listener would hear. We didn't really expect that a listener would retain every note of the first movement of Beethoven's Fifth Symphony. So it's a question partly of competence and performance. But in tonal pitch space, I develop an idea of I have a whole theory of functionality in that book, and I argue that what listeners are hearing in larger level are returns of event functions rather than of events themselves. So I think that's a possible solution to this problem. And it also, when I develop functions, then I start to develop units of analysis which are not just the event. this goes back to the discussion earlier about what is an object. At a larger level, perhaps the object is one of these little schemas that I just discussed. It might be, that a certain phrase ended on a tonic, or something like. In other words, there may be a kind of molecular level of analysis in which it's not the event that matters so much as the way that whole little stretch of music behaved. So I think this is a way to solve problems of large-scale structure, potentially. And it's also a way of reducing the depth of hierarchical embedding once you get to very large levels, which would ease memory load. So these are things that I think are worth exploring. Jack and I said to each other that if we ever return to music theory together, this is where we would start to try to develop these ideas in more detail. And then there's issues of agency and narrativity, which I will pass over now, but which I'll resume in my third lecture. Contour I'm going to talk about so much in the second lecture that I'll just skip it here, I think, for reasons of time. Yeah, well, universal grammar I'm leaving to the linguists. But I do want to talk a little bit about musical universals. I would like to distinguish between two kinds of musical universals. Cultural universals, which is to say some property of music that exists in all music of all cultures. This is, many writers over at least a century have tried to say what those things are, and then they have been roundly criticized for it, usually with justification. So cultural universals in that sense, I'd say are virtually impossible to establish, because there's always going to be an exception somewhere to anything. So what interests me is psychological universals, by which I mean is tendencies towards certain kinds of organization. So it's not an absolute thing, but certain tendencies are there, and often they happen at an abstract level. So if I were to say, what about a metrical grid? Now, here's a good example. Not all music has metrical grids. That is to say, not all music is metrical. So the alap of an Indian raga, perhaps Gregorian chant, depending on how you realized it in performance, certain kinds of recitative, a fair amount of contemporary music is not regular enough in its stresses to produce the intuition of a metrical grid. They're not periodic enough in the signal. But if the music is regular enough, then it will induce a sense of metricality, which can be represented by a metrical grid, which then is there. In other words, it's available there for structuring. So I would say that a metrical grid is a mental capacity which we have for music, which is there for the using. It doesn't mean that it will necessarily appear, but if it does appear, it will take certain forms. Like the same is true in multidimensional pitch space, which I'll talk about later in a later lecture. Certain musical scales are very common, others are not common. The question is why. If you investigate why, then you get into rather abstract mathematical properties of scales, which are very interesting. A number of people have written about this, including myself. I've already discussed tension and relaxation patterns, which I think have a physical, biological basis, probably. And then there are various kinds of perceptual and processing constraints, and I want to discuss a few of them quickly now. And I'll talk about numerosity and constraints on metrical organization. So Professor Dehaene, and actually I got onto all this through Mark Hauser and Elizabeth Spelke at Harvard, have talked about ways of dealing with number quantities. Humans have the natural number system, other animals don't. In other words, if you have, pick any number, pick the number 53, and there's another number 54. And it's we have a natural number system that's part of our mental furniture. But other animals also have the latter two, which is to say, the second one is accurate estimate of large quantities. So if you have, 60 blue marbles and 40 red ones, whether it's a chimp or whether it's us, we'll be able to tell that there's more of one than the other. And if it's 70-30, you'll be able to tell the difference between 70 and 30 and 60 and 40. In other words, we're able to estimate quantities even if we don't count them all up. And then there's the automatic recognition of very small numbers, usually up to 3 or 4. So when you just imagine sort of 3 marbles on a table, you see it and you take it in immediately. You don't have to think about that there's 3. But if there are 5, then you'd have to count a little bit. You'd probably group them into 3 and 2, or into 2 and 3, something like that. But the automatic recognition just happens. And evidently this is true of higher mammals as well. So I was brainstorming with Mark Hauser about this. Where would this show up in music? And we came up with several things. One is with polyphony. If you have 2 voices going on, you clearly hear the 2 voices. If you have 3, that's pretty much the limit. If I play a Bach chorale, you're hearing the whole thing. You're hearing the chord progression. You're not hearing out, unless you're highly trained as a musician, you're not going to hear out each line of each voice, the soprano voice, the alto voice, the tenor voice, and the bass voice. It was either Ravel or Hindemith. I don't know why it would be. There's such different composers. But one of them I heard said that you never hear more than 3. You can't really take in 3 voices of more than 3 voices of a fugue at one time, and I think that's basically true. So when Bach writes a 6-part Ricercare in the musical offering, you end up with this fantastic texture, but you don't hear all 6 voices. You just don't, and it's because the channel, our processing channel for hearing streams is limited. We can only go up to about 3. The same thing happens in timbral blend. If you have 2 violins playing, you hear the 2 violins. But once you start to get around 3 or 4, you start to get something called the chorus effect, where the quality of the strings changes, and the same is true with choruses, with of people singing, or even if you have separate instruments. Let's say you have a woodwind group. You might hear the flute, the oboe, and the clarinet. And you might identify them, but when they're all playing together, then pretty soon you start to hear this mass thing, which is woodwinds. So it's the same principle, which is to say, once you get around beyond 3 or 4, then you're into this kind of blend rather than hearing things out in detail. Then going to number C on this slide, we have grouping structure. You don't have groups like C, where you have a whole bunch of small groups and then all grouped together, or at least you usually don't. I suppose in repetitive music by Steve Reich or Philip Glass, you might. But most music would group as in D, where there are intermediate groups that group things into 2s and 3s. If you look at any Beethoven sonata, and I went through a whole bunch just to check this out, there is no place that I could find that I wouldn't have something like D. It never happens that you get anything like C. And then finally, a metrical grid. Metrical grids don't look like E. You don't have things like 5 beats without and then a strong one, unless the tempo is extremely fast, in which case everything becomes a blur for another reason. But you'll tend to have things like F, where the group is, if you have a metricality of 5 beats, it'll be da 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 instead of da 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 1 2 3 4 5 1 2 3 4 5 1 2 3 4. It's usually da 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 da, or it might be 3 plus 2 da 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 da. So generally metrical grids have strong beats 2 or 3 apart at consecutive levels. I will skip this slide for reasons of time, but I want to say a few things about ill-formed metrical grids in these terms. Well, maybe no, I'm going to skip that. Okay. Yeah. Well, let me just say that that the grids, if you work out all the permutations of possible grids, they tend to fall into 3 types, which can be described pretty easily. And you get a kind of combinatorial explosion of different possibilities within each type. But the actual number of possible grids is fairly small, which I think is an interesting fact. And there are other constraints on grids as well, but that would be another subject. So I will just end with a little peroration on the origins of music, which is something that interests, that a lot of people are talking about these days. So the question tends to be, is music adaptive in a Darwinian sense? Everybody knows that language must be adaptive because it's so useful, so of course the survival of the fittest and all that. But music doesn't seem to have any adaptive value. So various people come up with, hypotheses about this. So maybe it's social bonding, maybe it's synchronous behavior, maybe armies fight better if they synchronize. Motherese is, mothers and sometimes fathers speak to their babies with an exaggerated contour and usually in a high voice. Maybe babies learn how to separate words out that way. And so maybe it seems very much, it's almost like singing. So maybe that's another explanation. Darwin himself argued for sexual selection. Maybe music is so emotionally expressive and somehow in some way it is adaptive. So all these kinds of explanations and others have been offered. The trouble with all of them is that they're non-provable. Okay, it's a nice idea. I think they're probably all, I'm happy to say that they're all true. I just don't know. Then the other argument would be that music is a non-adaptive byproduct of other adaptive behaviors. This is what Steven Pinker argues in How the Mind Works when he claims that music is auditory cheesecake. Wonderful phrase. By which he means that music is just sort of touches the pleasure principle like crack cocaine. I guess I think music's a little bit better than that. But anyhow, that would be that kind of argument. In other words, that music uses other capacities that are adaptive. But I would ask instead, are these really the most useful questions to ask? And I guess I think the answer is probably no. And I would start off by saying that music, I hate it when people say music is this or music is that, because I hope even in this overview lecture I've made clear that music is not one thing. The theory of that GTTM and then especially in CPS that I've worked on over these years has many components. And some of them are shared with other capacities and others are not. The shared parts need not be adaptive for music itself. So, for example, grouping structure belongs to all audition, and it belongs to vision, and many of the same principles, Gestalt principles of vision, apply equally to music. In fact, the Gestalt psychologists started off with music at the very beginning of Gestalt psychology. And of course, grouping belongs to all kinds of capacities. Meter is shared with poetry, at least much poetry, and it's shared with dance, which I think is a very interesting and obvious fact, but it's there. And therefore it has to do with motions of the motion of the body itself. Contour and timbral patterning are shared with language, which I'll get into in some detail in my second lecture. So you don't need those things for music. You don't need to have music sort of invent them for some adaptive reason. Rather, those are capacities that are around which music can make use of. And even components that are unique to music may share abstract formats with other capacities. I've already talked about groups, grids, and trees, a little bit about tonal stability and tension. Pitch space is a kind of format I'll get into, and pitch attractions in my last lecture. So I guess the questions to ask, I think, are, what are the building blocks that music shares with other capacities? And a side question, but an interesting one, why is music so expressive? In this connection, Peretz provides evidence that music and language share the components of rhythm and contour. They do not share the components of the syntax, lexicon, and semantics, which belong to language, that linguistic syntax. or of specific pitch structures which belong to music. So this is the general picture that she draws based on neuropsychological deficits, and everything that I've said is consistent with that view. So I come up with this large diagram or flowchart which has these common structures: durational patterns, grouping, stress, meter, contours, timbral patterns. And then belonging only to music are consonants and dissonance, fixed pitches, intervals, and scales, pitch space, generally speaking, harmony and counterpoint, tonality, pitch prolongations, tonal tension, and attraction. Those are only in music. Linguistic structures, and I'm sure this is a partial list: syntactic categories and relations, word meanings, semantic structures, phonological distinctive features. So, from an evolutionary perspective, what's interesting, suggestive, is that the common structures belong not only to humans, but also to expressive vocalization in non-human animals. Think about your dog, or think about the birds in your backyard. They all, when they sing or they utter whatever they utter, they will have durational patterns. Their utterances will group in various kinds of ways, not just at one level, but in multiple nested groups. There will be stresses on certain parts of the signal. In the case of songbirds, you often get metrical structure. All utterances have contour. You get timbral patterns of recurrence, departures and returns of certain kinds of timbral patterns. And all of these utterances, which are pre-linguistic and pre-musical, are very often highly charged emotionally. They have to do with fear, something's dangerous, or it might be here's some really wonderful berries, come and help me get them, or it might have, I'm very handsome, here I come. All those sort of very primal emotions are part of those utterances, which are far in advance of the evolutionary development far in advance of language or of music. So these are all things these are structures which are the common structures which music and language share. So I end up with an hypothesis which is not only mine, but I simply do it from my point of view. Well, of course, these are fully constituted language. Music and language are uniquely human, but my hypothesis is that the common structures evolved first, and that music and language subsequently developed from this root as specialized yet overlapping human capacities. Thank you.